Welcome back to West Explains Best. Today we're doing a Khan Academy tutorial on square root equations, and this one is the intro. So let's go ahead and get started. It says solve the following equation for x. We're given that square root of 8x minus 1 is equal to the square root of 3 minus 4x. What we can do here is we can use the power rule. The power rule states if we have radical or any sort of equation, we can raise the equation by the same power to each side. The one thing we need to make sure of is that there are no extraneous solutions. And what those are is once we're done and we find our solutions, those aren't our definite solutions. We need to check our answer by plugging them back into the equation and seeing if it makes sense. In the meantime, we can go ahead and apply the power rule, which is squaring both sides. And so that undoes the square root. We get 8x minus 1 equals 3 minus 4x. From here, it's just like a normal multi-step equation. I'm going to add 4x to both sides. I get 12x minus 1 equals 3. I need to add 1 to both sides. I get 12x equals, oh sorry, I forgot the 1 there. 12x equals 4, and then I divide by 12. I get x equals 1 over 3. We should check that in terms of the context of the problem. We're going to have 8 times 1/3 minus 1. Take the square root of square root of 3 minus 4 times 1/3, and we're going to see if these create equivalent balanced sides. So we have square root of 8 over 3 minus 1. Is that equal to the square root of 3 minus 4 over 3? So this is where a calculator might come in handy, or if we want, we really should just convert these both into common denominators here. So we have square root of 9 over 3 minus 4 over 3. So in both cases we get 5 over 3, the square root, and so we're good. This checks out. The probable solution became an actual solution, and we had no extraneous solutions, something that would make the equation not make any sense. So we're going to use 1 over 3 for our answer. Let's use the fraction button here, 1 over 3, and submit it. Good job, nice work, it says. Okay, so now we're on to, this one is more typical. We can still use the power rule here to undo the square root sign, so we're going to square both sides. In doing so, we get 2 over 3y minus 7. A common mistake I see is people want to square these inside for some reason. No, you're squaring it and you're undoing the radical, so the radical goes away. So this is equal to 81. 9 squared equals 81. So we're going to add 7 to both sides. 2 over 3y equals 88. Now we need to multiply both sides by 3 over 2, with the reciprocal, 3 over 2. We get 44 times 3, because 88 divided by 2 is 44, so we get 44 times 3. That gives us 132. Y equals 132. We need to check that answer, so we're going to plug it back in. 132 times 2 over 3 minus 7, is that equal to 9? Well, the square root, of course. Is that equal to 9? So 132 times 2 divided by 3 minus 7, 81. So square root of 81, is that equal to 9? Yes, it is. We are good to go. So we're going to type in 132 for y. 132. Excellent. Next question. Okay, so the general rule is if you have anything in addition to the radical, you want to move that stuff to the other side. You only want a radical by itself on one side. In this case, we already have that. We could also have something like, what if there was like a 2 out in front? You'd want to divide both sides by 2 first. That's not the case here, but I'm just saying you want to make sure the radical is by itself before proceeding any further. So it's not, so we can proceed. We can use a power rule, and let's get started. So we apply the power rule. We get square root, oops, sorry, that undoes the square root. So we get 8 minus 4w. Now on the right side, we are going to get a binomial squared. So we're going to have to FOIL this, or LOIF, or whatever you want to call it. So on the right, we're going to get 169 plus 13w plus 13w, 26w plus w squared. So the first thing I want to do is get, or this isn't the first thing, but you get what I'm saying, plus 4w to each side, plus 4w, and we're going to subtract 8. Subtract 8. So we get 0 on the left, that's what we want, and I'm going to rearrange this so it's in descending order. W squared plus 30w and plus 161. Oh, well, that is a doozy. So hopefully we can find some factors of 161. I think it's 23, 23, and 7. So I use my calculator to help me there. But essentially what you're going to do is you're going to factor this. And I know some of you don't really like factoring, but I'm sorry, this is the problem at hand. If factoring doesn't go away, it's going to stay forever, unfortunately, for some of you. Okay, besides the point. So again, when we're factoring, looking for the factors of the first term, goes in the first slot. And then the factors of the last term go in the second slot. So the w is easy. We get WW. 161 is a little tougher. 161 is a multiplication of 23 and 7. So I need to put 23 and I put 7 here. And they're both positive because the middle term is positive. Do 23 and 7 add up to give me 30? Yes, they do. So those are our two solutions. So we need to set both of these solutions to 0. So w plus 0 equals 7. W plus 23 equals 0. Therefore, w equals negative 7. W equals negative 23. Finally, we have to check these solutions. First, let's check negative 7. We have the square root of 8 minus 4 times negative 7. Is that equal to 13 minus 7? Plus negative 7 minus 7. You guys get it. Okay. So we have 8 plus 28, is that equal to 6? We get square root of 36 equals 6. Good to go. So square root of 7, we're good on. Now we need to check, we'll do this in orange, negative 23. 8 minus 4 times 23. We'll take the square root of that. Okay, Houston, we have a problem. 4 times 23 is 92, and we do 8 minus 92, and we get, what is that? Sorry, negative 84. Negative 84. We cannot take the square root of that and get a real number. This is an extraneous solution. So I'm glad we saw this, because this is extraneous. So our only answer is negative 7. The giveaway here is that it doesn't give 2 slots, so if you put 2 answers, definitely would have got it wrong. Holy macaroni. Well, this isn't as bad as it seems. It does got to look bad, but I'm going to square both sides. Square both sides. We get 2z squared minus 7z plus 49 equals z squared plus 7z. It's not as bad as it seems. So we subtract z squared, subtract 7z, subtract 7z, subtract z squared. So we get z squared minus 14z plus 49, that's a 4, equals 0. We're going to put 2 parentheses, get this started. This is factoring a trinomial, equals 0. First slot goes there, and that's going to be z and z. Second slot, last term, 49. Well, that's obviously 7 and 7. Now, is it positive or negative? I noticed that the middle term is negative, so I'm going to make these both negative. And now we have a double root, but it's z equals 7. Why do I know that? Z minus 7 equals 0. Add 7. Therefore, z equals 7. Let's check our answer. So we're going to put 7 in for both of these on both sides of the parentheses. Let's go up here. Erase. 2 times 49 minus 49 plus 49. That's interesting. And then that's on the right side. On the left side, oh, the square root, sorry. On the right side, we get 49 plus 49. 49 plus 49. Let's do the right side first. That's a little easier. Square root of 98. We're just going to leave it like that because hopefully the left side is going to be exactly the same. We get 98 minus 49 is 49. Plus 49, 98. Guess what? We get the same thing on both sides. Good to go. No extraneous solutions. Shoot, I already forgot. What do you know? 7. That's right. Lucky number 7. Okay. Hopefully with that, you'll be hearing the same sound. Hopefully you got it now. I can't wait to see you next time on Wes Explains Best.